For problem 5-10, part A, we're asked to draw all the forces acting on the cylinder and the block. So first, for the cylinder, we have mg pointing down and a supporting force pointing up, as well as the torque from the string pointing down. Now on the block, all we have is mg pointing down and the tension pointing up. For part B, there are 3 parts. In part 1, we're asked to look for the acceleration of the block. So to do that, we're going to use a sum of forces is equal to ma. As we know from the previous part, there are only 2 forces acting on the block. So that would be the m and tension, so that would equal the mass times acceleration. Now we have to find tension. To do that, we have to look at the torque. Torque is equal to R cross F, and in this case our force is tension. It is also equal to I alpha. So I is given in the problem as 1/2 m1 r squared, and that is equal to r. So we can cancel those out, and we're left with tension is equal to 1/2 m1 r alpha, but we still don't know alpha. Keep in mind, alpha is equal to A over R, so we plug that back into tension, and we get 1/2 m1 r times A over R. Cancel those 2 out, and we get the tension is equal to 1/2 m1 A. Now we plug all of this back into this equation, starting up here again. M2G minus the tension is equal to that, and from here you just simplify until we get the answer. So you add 1/2 m1a to both sides. You can take out the a. And divide both sides. Now to get the answer in the same format, just to get this fraction out of the bottom, multiply the entire thing by 2, and you're left with the acceleration is equal to 2 m2g over 2 m2 plus m1. Sorry, that's kind of messy. For part 2, we are asked to find the tension in the cord. Thankfully, in part 1 of this problem, we already derived an equation for tension, which ended up being 1/2 m1a. We just solved for a, so we plug that back in, and we get 1/2 m1 times 2m2 g over 2m2 plus m1, and that is your tension. For part 3, we are asked to find the angular momentum of the disk as a function of time. So the equation for angular momentum is equal to r cross linear momentum, which is also equal to I omega. Keep in mind that V is equal to R omega. So omega is equal to V over R. Plug that back in, so we end up with I V over R, but we need V as a function of time, which we aren't given. So we have to look at the acceleration that we just found. And acceleration is also equal to the derivative of velocity. Oopsies. There you go. Multiply dt over and take the integral to get velocity. Oopsies. As a function of time. Sorry, I'm going to rewrite this up here. V is equal to the integral of that, which ends up being 2 and 2g over 2m2 plus m1, all of that multiplied by t. So now that we have velocity, we can plug that back into here. Sorry, I'm going to erase this so I have more room. There we go. So we've got L is equal to, and I is given to us in the problem, so plug that in. Plug in V. Divide the entire thing by R. From here, it's just simplifying, and you end up after at M1, M2, G, R from here, T from there, all over 2m2 plus m1, and you're done.